Hello PLP geometry. Welcome to the first video of Unit 5, right? So Unit 5 is going to be titled, let me get my pen the right width. One sec. There we go. Unit 5 is going to be titled Parallelograms, along with the coordinate plane. Now, I would say that the state test, right, loves triangles much more than parallelograms. So the first half of this lesson, unit, I should say, but the coordinate plane stuff, oh my goodness, the state test loves the coordinate plane because that's their connection between Algebra 1 and geometry. So again, when we get to midway through the lesson, got to make sure we perk up our ears with this coordinate plane stuff. So this first lesson is actually more generic. It's not strictly about parallelograms. We're going to talk about angles in polygons. Angles in polygons. So we talked about angles in triangles back, I think, in Unit 3. So now we're going to generalize it to more polygons. So the first thing we're going to talk about here is the polygon interior angle sum theorem. The polygon interior angle sum theorem. The name's more complicated than the actual idea, right? The polygon interior angle sum theorem. And it says that the sum of the interior angles, I'm going to use the angle symbol if you don't mind, of the interior angles of a polygon with n sides is 180 degrees times n minus 2. And that's your formula. Okay? So, for instance, we're going to use a pentagon as an example. And a pentagon has 5 sides. Now, I'm purposely not going to make this look like a pretty pentagon, right? So I don't want all the sides to look the same length. So as I just did that was probably bad. Let me redraw this, sorry. So let me draw this first side like this. I'm going to make the first side a bit longer. Then we'll do like a little short side, another short side, maybe a medium side, and then that side, right? So this is purposely not a nice looking pentagon. Again, pentagon means 5 sides. And we're going to call it 1, angle 2, angle 3, angle 4, angle 5. Okay? So to find the sum of these 5 angles, I would just do 180 times 5 minus 2, because this pentagon has 5 sides. So n for this picture would be 5 sides. And that's why 5 goes right there. Well, 5 minus 2 is 3. And if you just use a calculator, 3 times 180 is 540 degrees. So these 5 angles would have a sum of 540. So some problems just say find the sum. Other problems want you to find a missing angle. So that means that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 plus the measure of angle 5 would equal, in this picture, 540 degrees. Okay, so those are interior angles. Okay? Now, what about our exterior angles? Okay, let's talk about that. So, the polygon exterior angle sum theorem. Again, the name is much more complicated than the actual idea. Okay, so this idea says the sum of the exterior angles of any polygon, no matter how many sides of any polygon, is 360 degrees. Boom. That's it. It doesn't matter if this thing has 8 sides, 20 sides. I don't care how many sides. The extra angles will have a sum of 360. And you might be saying, well, what are the extra angles? Well, let's try to draw that same picture again. And again, it's not going to be identical, but it's still going to be a pentagon. Okay, so there's my pentagon, right? My 5 sides. So when we talk about extra angles, we're talking about extending the sides. So if you take, like, say this top left corner, and you extend that side horizontally, that could be an extra angle. And then I'm going to take this side and extend it down. That's an extra angle. And I'm going to take this side and extend it to the right. Now there's the extra angle. And extend this side up. There's the extra angle. And extend this side up. There's the extra angle. So you have as many extra angles as you do interior angles. So if I take a look at this problem, it doesn't matter that this has 5 angles, it could have 7 angles, 9 angles, I don't care. The measure of angle 6 in this picture, plus the measure of angle 7, plus the measure of angle 8, plus the measure of angle 9, plus the measure of angle 10 is going to be 360 degrees. Perfect. Okay, so now, what about if we deal with a nice polygon, right? This was not a nice pentagon because the sides were all different. Well, what if we deal with what's called a nice pentagon? In geometry, the word, when I say nice, I mean is regular. So a regular polygon. So for a regular polygon, this means that all sides are congruent. And all angles congruent. All sides congruent and all angles congruent. So if we take a look at a triangle, right? That's the most basic polygon. That's the first polygon. So we talked about what's called an equilateral triangle. That is a regular triangle. So I'll do my best to draw all 3 sides the same. So we talked about all 3 sides the same, all 3 angles the same. And we actually know that if we take 180 and divide it by 3, we get 60. Each of these angles is 60 degrees. Okay, next, 4 sides, right? That would be the square. So a square is a regular quadrilateral because it has all sides congruent and all angles are congruent. Now, for a square, we typically mark the 4 angles with a right angle because they're all right angles and 90 degrees. Now, that is because in a quadrilateral, the sum is 360 and we divide it by 4, and that gives us 90 degrees. The next one would be a pentagon. Now again, to draw a regular pentagon, we just have to kind of eye it up. So try to draw all of your sides the same length, all of your angles about the same length, or the same measure. So these 5 sides would be the same. These 5 angles would be the same. And now for a pentagon, the sum of the interior angles is 540. So we would divide it, and again, oh shoot. Let me draw that again. Sorry about that. So if I draw the pentagon, it's a bummer. My bad. So again, all these sides are the same. So all the angles are the same. And if we take 540, which is the sum of their 5 angles, and divide by 5, we get 72 degrees. So each of these angles is 72 degrees. I'm not going to draw them all. And so on, right? You could do the regular hexagon, regular heptagon, right? I'm not going to make you memorize all these names, but this is it. So how did I figure out these angle measures? Well, we're going to talk about that because it's important, right? Regular figures, most of the time in life, we see regular polygons. So to find the measure of each angle of a regular polygon. Okay. 1. If it's an interior angle, we're going to do 180 times n minus 2, which is the sum of the interior angles. That's how I got those numbers, 360 and 540. But then you divide it by the number of sides. So let's do an example. So let's use a regular hexagon. A hexagon has 6 sides, so n equals 6. And again, I'll try to draw a hexagon so it looks like this. Try to draw all sides the same. 6 sides if you can. Okay, so there's my regular hexagon. So to find the measure of the interior angle, right, I'm going to take 180 times 6 minus 2 and divide it by 6. That's 180 times 4, which is, I think it's 720, right? 180 times 4 would be 720. Let me double check that. 180 times 4, yep, is 720. And when you divide 720 by 6, you get 120. So each of these angles in here, right, because all these angles are congruent, each of those angles is going to be 120. And I'm going to strategically put it right here because we're going to talk about something in a minute. Okay. Now, what about, and I'll change the yellow, what about the exterior angles? So to find an exterior angle, right, the sum is always 360, and we're going to divide that by the number of sides. So there's your formula there. So in this picture, I'm going to extend this side to make this exterior angle right here. You would take 360 and divide it by 6, and you would get 60. This angle is 60. And now, 60 degrees. And now, this gives me an important point, right? On any polygon, whether it's regular or not regular, notice the interior and exterior angles. They are supplementary. That reinforces the idea we talked about with the triangles. So your interior angle plus your exterior angle is always going to equal 180 because they are supplementary. Right? And there you go. Okay, so this is your first video. I'm going to make a second video just talking about how to construct a regular hexagon in a circle. That's one of the constructions the state wants you to know. So I'm going to do it separately so you can look at it easily and use it to help yourself out. Okay, so stay tuned for video 1B. Sorry I didn't call this video 1A.